All right, kiddos, today we're going to talk about ellipses. These notes are a little bit longer, so if you are watching these because you are absent, then you need to have about 30 minutes. So here we go. Objectives, we're going to write an equation of an ellipse in standard form and sketch the ellipse. And we're going to use the properties of ellipses to model and solve real-life problems. And we're going to find eccentricities of ellipses. So what is an ellipse? Ellipse is a set of all points x, y in a plane, the sum of whose distance from two distinct fixed points called the foci is constant. So what does that mean? It means if you take this distance right here and we add d1 and d2, it does not matter where you put the point on your ellipse, d1 and d2. You could come over here, d1 and d2. That distance is going to remain constant, and I will give you a visual example of this in class. All right, so this is not in your notes, but just kind of an FYI. Remember, the ellipse is when we take a plane and we cut that double nap cone, and the plane is not parallel to the bases of the cone, so it slices through one cone, so it doesn't form a circle because it's not parallel. And this just gives you a good oversight of some terminology that we're going to use. We could have a horizontal or vertical major axis. So our longer axis is our major axis. And when I look at that longer axis, this distance is A, whether it's horizontal or whether it's vertical. And this distance is B, whether we are horizontal or vertical. So our major axis is the longer of our two axes. The minor axis is the shorter of the two axes. Then our vertex. The longest axis, the two endpoints, are called the vertex, and it doesn't matter if your longer is horizontal or vertical. They're called the vertices. And then when we have our shorter axis, the endpoints of the shorter axes are actually called the co-vertices. So you'll become very familiar with these terms in the next 10, 15, 20 minutes. All right, if our ellipse is not centered at the origin, these diagrams are on your conics by visual notes that we have handed out to you, so you might just keep them handy. Just notice when we shift things left and right, we tend to add to the left and right. We tend to add to the h value. When we shift things up and down, we add and subtract from the k value. And it doesn't matter if it's the foci or if it is the vertice or the co-vertice. Anything left right is added to the h. Anything up down is added to the k. All right, and here's just a table form for those of you who like to have it organized like this. Try to give it to you a couple different ways. The biggest thing you need to understand about the equation of the ellipses, the numerators look just like the circle, and they are x minus h quantity squared and y minus k squared. The only difference in the equation of the ellipse is the location of the a value. So if your a value is located underneath the x, you have a horizontal major axis. And if the a value or the larger value is located under y, you have a vertical axis of symmetry. So your center is HK, and again, if you have a horizontal movement, which we will have here for our vertex and our foci, we add to the x. Over here on the right, we have a vertical major axis, so we add that a value to and the c value to the k value because it's on the vertical or up-down axis. Our major axis is horizontal with a length of 2a, and our minor axis is vertical with a length of 2b. If you are doing the horizontal major axis, and then it switches for the y. So if your vertical axis is major, then the longer axis is always 2a. It's really just the best way to remember that. So if you think about it on these pictures, here this is a, and here this is a and a. And then B is your minor axis, and here B is your minor axis. All right, moving on. So we're going to write the equation of an ellipse centered at the origin. So I have vertices at -8 and +8. And I have co-vertices at 4 and -4. And honestly, that allows me to sketch my ellipse, and it takes a lot of practice to make these look decent at all. So now I am going to take and write the equation of my ellipse. So if you think of the standard form equation, it is x minus h squared over a squared plus y minus k squared over b squared equals 1. I put the a underneath my x because my x-axis is definitely longer than my y-axis. So looking at my picture, the length of this is 8 and the length of this is 4. So 8 is going to be my a value and 4 is going to be my b value. I am centered at the origin, so this is going to give me x squared plus y squared, and I'm weird, I always do my numerators first. And then my denominators, x squared is going to be over 8 squared, which is 64, and y squared is going to be over 16. Now, I need to find my foci. So c squared equals, and it's always a squared minus b squared, and it's really always your biggest number minus your smaller number. So in this case, it's going to be 64 minus 16. Remember that this is a squared right here. You don't have to square it again. So at this point, c squared is going to be 48, and c is the square root of 48. Now, quick estimation, the square root of 49 is 7, so 48 is pretty close to 49. So it's approximately 6.9. So if I want to come over here and add my foci on my graph, then I can do that. The other thing we have going on is if you want the coordinates of the foci here, they are on my horizontal axis. So it's going to be plus or minus square root of 48. And we're going up 0 because my center was at 0, 0. Normally, if my center wasn't at 0, 0, my h value would go right there. All right, perfect. Moving on. Okay, so you know me, visual Miss Schwartz. Write an equation of an ellipse with foci negative 2, 2 and 4, 2. So naturally, first thing I am going to do is plot those points, negative 2, 2 and 4, 2. And the thing that tells me is that my center is smack dab here in the middle. So that's really telling me the coordinates of my center are over 1 and up 2. Then the major axis has a length of 12. So literally, I'm going to start at my center and I'm going to count to the right 6 here, and I'm going to count to the left 6 here. And that tells me that if my major axis has a length of 12, that my a value is 12. I can also essentially count my c value. Remember that the c value will be the distance from here to here, from your focus to your center. So in this particular picture, it is 3. Now, in order to write the equation of my ellipse, I have to have that b value. So c squared equals a squared minus b squared. So if I look at this and I start working on this, I have, oh, I made a little mistake up here and I need to fix that. My major axis, the length is 12, which means my a value is actually 6. Sorry about that. So everybody make sure a is 6. So if I look at this, c squared, c is 3, 3 squared is 9, a squared is 36 minus my b squared value. So if I subtract that 36 over, I get negative 27 equals negative b squared. So b squared is 27, and b is the square root of 27. Again, for graphing purposes, just estimate. The square root of 25 is 5, so this is probably approximately 5.1. So if I have to graph it, I'm going to go 1, 2, 3, 4, 5.1 to the north, and 1, 2, 3, 4, 5.1 to the south. That is enough to allow you to graph your ellipse. And as you graph this, if you notice, our horizontal and vertical major axes are pretty close to the same length. This has to do with the eccentricity, which we're going to talk about here at the end of this lesson. So, as for writing these equations, I have my center, HK, right here. So this is going to be x minus 1 squared over something plus y minus 2 squared over something equals 1. I have a horizontal major axis, and my A value is 6, so this here is going to be 36. I have a vertical minor axis right here. I already know what b squared is, so b squared is 27, so I can put 27 right here. All right, that fulfills the requirements of example 2, so we are going to move on. Okay, I have a major axis now that's 14 units long, so that will tell me that my A value is 7, and it's parallel to the y-axis, so my vertical is my major axis for this next problem. The minor axis is 10 units long, so that tells me that B is 5, and I know that my center is at -2, 1. It says write an equation of the ellipse in standard form and then convert it to general form. Technically, the graph is there if you need it, but you are not required to graph this one. So, because of the location of my center, I always start there because I am a major creature of habit. X minus the -2 is x plus 2 squared. This is an ellipse, so that sign is plus. And then you have y minus 1 squared. And these conics, other than the circle, always equals 1. So then my major axis is vertical, which means my A squared goes underneath my vertical. 7 squared is 49, and 5 squared is 25. That is my standard form of the ellipse. So basically what I'm going to do is I need to move my denominators to the other side. So I'm going to multiply each side of this equation by 25 times 49. So over on this side, I'm going to multiply by 25 times 49. And what happens is each of my denominators will cancel. So when I distribute the 25 here, my 25's cancel and leave me with 49 times x plus 2 squared. And then when I distribute my 49 here, my 49 cancels, but it leaves me with 25. Oh, that's a y, minus 1 squared. And over here, if you multiply 25 times 49 very quickly, you get 1225. So I would hit pause, expand your binomials, and move your 1225 to the left-hand side. I'm going to do it very quickly, so keep up if you can. So 49 x squared plus 4x plus 4 plus 25. This is y squared minus 2y plus 1 equals 1225. You distribute 49x squared. Distribute, you get 196x. Distribute plus 196 plus 25y squared minus 50y plus 25. And technically I'm moving that 1225 over. So, and that equals 0 now. So now, remember, your x squared term comes first. Your y squared term comes second. Your x term comes third. Your y term comes next. And then I'm going to take all the numbers that are constant and I'm going to combine them. And in this problem, when you do that, you get 1004. I change colors. And that equals 0, because your standard form always equals 0. Not standard, your general form. So this is general form. And you know that this is an ellipse because this A value and this B value are different. In a circle, it would be the same, and that sign right there is a plus. All right, moving on to example 4. You're finding the center, the vertices, and the co-vertices of this ellipse and giving us a quick sketch. So when I look at this, the first thing I'm going to do, just like we did in the circle, I'm going to group my x's, so x squared plus 6x. And then I'm going to group my y's, y squared and my 8y. And I'm going to move my 9 to the other side. So over here, completing the square is pretty easy. I'm going to add 9 here, which means I need to subtract 9 over here. For this, I need a GCF, so I have 4, which will leave me with y squared minus 2y plus something. So now, if I do that, 2 divided by 2 is 1, so I'm adding 1. But remember, I didn't really add 1. I added 4 times 1, which is 4. So now I'm going to come down, write these as binomial squared. So x plus 3 squared plus 4, got y minus 1 squared. On the right hand side, oh, this should be a plus right here. I added 9 and I added 4, so my 9s cancel out. The math on that's pretty easy. If you think back, the equation of conic sections always equal 1, so I'm going to divide everything by 4, and this is going to give me my standard form of my ellipse. X plus 3 quantity squared over 4, and I have y minus 1 quantity squared over 1, and that equals 1. So my my center is going to be HK. So my center is going to be -3, 1. So I can come over on my graph and I can graph -3, 1. Then my vertices, I am going to take and add A. So A is 2 and B is 1. So I'm going to take -3 because it's on my horizontal axis, and I'm going to add and subtract my A value, which is 2. So this means that my vertices are at -3 plus 2, which is -1, 1, and -3 minus 2, which is at -5, 1. So I'm going to go ahead and plot my vertices. My vertices are at -1, 1, and -5, 1. A little teeny ellipse. Alright, so now my co-vertices, my x value stays the same, but this time I'm going to take my y value and I'm adding b. So this is plus and minus 1. So my co-vertices are going to be -3, 1 plus 1 is 2, and -3, 1 minus 1 is 0. So now I can add my co-vertices, -3, 2, -3, 0, and this are my co-vertices, and that is enough to graph that ellipse. All right, so supposed to find my focus, so find a little bit of room up here. So my focus is going to be c squared equals a squared minus b squared, which is 4 minus 1, which is 3. So my foci, you're going to take your major axis, which is -3, and then you're going to add the square root of 3 and keep y the same, 1. And then you have -3, and you're going to subtract square root of 3, and the y value stays 1. So really your foci are just going to be right here and right here. All right, let's continue to move on. Okay, we're going to talk about the eccentricity. So the eccentricity basically measures how oval our ellipses are. And your formula for eccentricity is going to be E equals C over A for every ellipse. And if your eccentricity is close to 0, it means that your graph is more circular. And if we are closer to 1, then our graph is more oval. So you can look at the pictures and kind of determine that. So if we look here, it says find the eccentricity of the ellipse and determine if it's more circular or more oval. So if I look at this, this is my b value, this is b squared, this is a squared. So in this particular problem, c squared equals 100 minus 36. 100 minus 36 is 64, so c equals 8. My eccentricity is going to be c over a, which is 4 over 5, which actually isn't even approximately, it's actually exactly 0.8. And because this is close to 1, this means my ellipse is actually going to be more oval versus more circular. All right, that's all I got for you on ellipses. So we will be tackling our homework probably in class tomorrow or at home tonight, either way, however it works for you at this point in the year. So if you have any questions, feel free to ask. Otherwise, I am signing off for tonight. Talk to you later. Bye-bye.